All right, ladies and gentlemen, welcome back, and the excitement continues for our quadrilateral discussion. In our final section of quadrilaterals, we are going to discuss trapezoids and kites. The overall goal is to identify and use the properties of trapezoids and kites to both compare and contrast these quadrilaterals and use the mid-segment theorem for trapezoids to find missing length measures. All right, I'm excited for this next couple of videos coming on up. In this video, we are going to define what a trapezoid is, and we are going to identify 3 properties of trapezoids. All right, in our next videos, we will look at some more examples. First and foremost, let's talk about a trapezoid. This should be review for most of us, but if not, that is okay. What is a trapezoid? Well, we've seen kind of the typical look of a trapezoid before. There are 2 parts to a trapezoid. There are the bases and there are the legs. The bases of a trapezoid are the sides that are parallel to one another. So the bases are parallel to one another. The non-parallel sides are called our legs of the trapezoid. And last but not least, the base angles are formed by the base and one angle. So I would call angle D and angle C base angles, and I would call angle A and angle B another pair of base angles. So what happens if the 2 legs are the same length? They are congruent to one another. Well, if we remember correctly back when we had triangles, what did we call a triangle that had 2 congruent legs? You got it. We called them isosceles. And so we have isosceles trapezoids. So I'm going to go through 3 characteristics of isosceles trapezoids in the remainder of this video. So first and foremost, what do we know? Isosceles trapezoids, all right? If a trapezoid is isosceles, then the pairs of base angles are congruent, all right? Not to each other, but the pairs are respectively congruent. So B and C, the top pair, is congruent, and A and D, the bottom pair, are congruent as well. Our next on the list, all right, if we have an isosceles trapezoid, it's also true that if the trapezoid already shows a pair of congruent base angles, then it's enough to prove the trapezoid is isosceles. And so this is a prime example of the converse in play. If A and D are congruent, then the trapezoid is isosceles. And last, but certainly not least for this video, our diagonals of our trapezoid. If the trapezoid is isosceles, the only way this happens, ladies and gentlemen, is if the diagonals are congruent to one another. Alrighty, so there are 3 big characteristics for isosceles trapezoids. All right, we have isosceles trapezoids knowing that the diagonals are congruent. All right, we know that if the base angles are congruent, then it's an isosceles trapezoid. And if it's an isosceles trapezoid, both pairs of base angles are congruent to one another. Let's take a look at one example of how we can put this into practice a little bit. All right, so it says find the measure of each angle. I want to know what the measure of angle D is. So what do we know? We know that angle C and angle D are base angles of this trapezoid. How did I know it was a trapezoid? Because it had 1 pair of parallel sides. But specifically, this is an isosceles trapezoid because the legs are congruent, thus making our 2 base angles congruent, and the measure of angle D is also 101 degrees.